Hey guys, welcome back to Learning and School. So I'm going to start us off with a little bit of review from what we did before. So here's the sample diploma questions. Feel free to pause the video and try them on your own and see if you can figure them out, but I will go through them. So in a chemical reaction represented by the equation above, the proton donors are, so you can see that HNO2 turns into NO2 minus. So the only way that HNO2 can turn into NO2 minus is if it gives its proton to H2O, right? And if we make the equation go the other way, where H3O plus is turning into H2O, then H3O plus has to give up its proton to NO2 minus, which would give its H back and would return everything. So proton donors are HNO2 and H3O plus. So B is going to be the correct answer. Which of the following descriptions applies to vinegar? So remember that vinegar is a weak acid. If you take a look on your data booklet, you can see that there's only 3 acids that are strong, those top 3 on your chart in your data booklet. So that means that it's weak, and it ends in COOH, which means it's an acid. So it's a weak acid that partially ionizes. So B would be the correct answer. So in this one, which of the solutions would not conduct electricity? So we are looking for a molecular substance. So that means all nonmetals. So we can see with the vinegar, it's COOH, which means it's an acid. This is neutral, but Na is a metal. It's on the left side of the periodic table, and Li has OH in it, which usually means it's a base. So the sugar solution is all nonmetals. They all are on the right side of the data booklet on the periodic table. So because it's molecular, it will not conduct electricity. So here we have a 0.1 mole per liter solution of benzoic acid and a 0.1 solution of hydrochloric acid. So if you take a look at your data booklet, you're looking for whether it's a strong or weak acid. And if you see HCl on your data booklet on that list of acids and bases, HCl is one of the top 3, which makes it strong. Right? And this benzoic acid is not top 3, which makes it weak. So our definition of a strong acid is it makes lots of ions, it makes lots of H3O+, and if you have lots of H3O+, you'll conduct electricity. So HCl will be the one that conducts the most electricity because it makes the most ions, and the ions that it makes is H3O+. So here's our assignment from before the break. So just a little bit of review. So acid is a proton donor. That's our only definition. Dissociation is when you take something like NaOH and it breaks up into ions. So anything that breaks up into ions would be dissociation. Wait, where you went through this? Yeah, we already went through this. We already did this. We already did this before our lab, so we actually don't need to go through this. Oh, that's perfect. Okay. So here's our pH lesson. So we're going to describe the relationship between pH and hydronium ion concentration. We're going to calculate pH from hydronium ion concentration. And we're going to calculate concentration for strong monoprotic acids and bases. And we're going to do a little bit of whmis. So this is the new whmis symbols. I'll just throw them all up here. So most of them you've seen before. Flammable, obviously, like things like propane would be flammable. This one you don't need to know, oxidizing, because they want you to know like everyday stuff, and everyday stuff isn't oxidizing, so don't worry about that one. Another gas cylinder would be propane. And something that would explode would be propane. So those are like common ones that we can see, like a propane gas tank for barbecuing. Biohazardous and infectious material would be things like blood. So needles, syringes, those would have biohazardous and infectious material. Corrosion would be any acid or base. Exclamation mark just means that, like, watch out for it. This can cause less serious health effects. It won't kill you. The skull and crossbone can kill you, like arsenic, poisons that will kill you immediately. This exclamation mark means that it'll hurt you, but it'll cause less serious health effects. Like an acid could cause less serious health effects. This health hazard would be things that you wouldn't want to breathe in. Again, acids are something that you wouldn't want to breathe in. And then this environmental damage would be something like mercury, which you wouldn't want to dump into a river. So that's what you need to know about whmis. So water is a molecular substance, right? Water is H2O, and these are both nonmetals, which make it molecular. And does water conduct electricity? Well, molecular things, no, should not conduct electricity. So, yeah, it shouldn't. But what happens with water is it actually does make some ions. Water can give up its proton to water and make H3O plus and OH minus. But this by itself doesn't happen very often, so it only happens every 2 water molecules out of a billion. So you have a better chance of winning the lottery than being one of those water molecules that actually does this. So that means it does conduct electricity, but it's just very, very weak, very, very few ions, so very, very little electricity. So the concentration of hydronium in pure water is 1 times 10 to the negative 7, so that's very, very small. And it's the same for hydroxide ions. So both hydronium and hydroxide, so this is hydronium here, this is hydroxide, has this concentration. So very, very small. And this is what we measure concentration in. You don't really need to know what it is, but it's just a measurement for concentration. So things that are very, very strong acids can have a concentration of 10 moles per liter, right? And something that's a strong base isn't going to have a lot of hydronium in it, so it can be 10 to the negative 15. So this is a huge range, right? They're trillions and trillions of times different between a strong acid and a strong base. So we don't want to deal with things with this big of a range. So this awesome guy here with there's a little mustache on him. He has an awesome name, Soren Sorensen. Cool parents. He used a base 10 logarithm system, which sounds a lot scarier than it actually is. So what logarithms are is a base 10 logarithm of a number is the power to which you raise 10 to equal that number. So let me explain that. So 10 to the 1 just means 1/10, right? Which is 10. So if I type into my calculator log of 10, it'll give me 1. Right? So that exponent here is what the log tells you. If I say 10 to the 2, which is just 10 times 10, 10 times 10 is 100. And if I typed in log of 100, then that would give me 2. Right? Same thing with 10 to the negative 2, which is 0.01. Well, if I typed in log of 0.01, it would give me this exponent right here, which is negative 2. So that's how they work. It's not that complicated. So we said that H3O plus has a concentration of 10 to the negative 7, right? Or 1 times 10 to the negative 7, but 1 times doesn't do anything. So if I said log of 1 times 10 to the negative 7, well, that would give me negative 7. But we don't want a negative answer, so if I make this negative, then this will make this positive, and it gives me 7, because water has a pH of positive 7. So that's where we get this formula here. So to find the pH, it's going to be negative log of H3O plus. So significant digits. So for pH values, the only numbers that are significant are to the numbers right of the decimal point. So this has 2 numbers to the right of the decimal point, so it's 2. This has no numbers to the right of the decimal point, so it's 0. So it's just a special thing with pH. So regular number like 4.12 would include all of them. So this has 3 sig digs. If I did 4.123 times 10 to the 3, and I wanted to find out sig digs, it's these numbers that are significant, and all of them would count. So it would have 4 sig digs, but pH is just different. We only include them to the right of the decimal place, so we don't include numbers before the decimal place. So we can do this calculation. You can do it on the calculator. What you need to type into your calculator is you need to go negative log of the concentration of hydronium ions. So 3.8 times 10 to the negative 3. Right? Oh, I don't have my calculator. I'm doing this at home. I don't have my on-screen calculator. I'll get that program installed in a little bit. So you'll have to work it out with your calculator, but just type in a negative. Don't type in minus, type in negative, and then go log, and then type in 3.8 times 10 to the negative 3. And if you did everything right, your calculator should tell you 2.42. Right, same thing here. We would just negative log that number, 4.42 times 10 to the minus 13. And if I type in negative log of 4.42 times 10 to the minus 13, it should give you 12.35577. And I guess I didn't really talk about sig digs. I should talk about sig digs with this. So this is just a regular number. So in this regular number, all these count. So this has 3 sig digs. So we want to give our answer to 3 sig digs as well. So these 3 after the decimal place, because this is a pH now, these 3 are the significant one. This is a 5, so we'd have to round that up. So we'd want to give 12.355. So that would be our answer to 3 sig digs. I'm just going to go back to the last question because I didn't talk about sig digs. But this is just a regular number, so this has 2 sig digs. This is a pH, which is 2.42. So this has 2 numbers after the decimal place. So this has 2 sig digs, this has 2 sig digs. So that would be correct. So can pH be less than 0? We'll just test it out, right? They give us a concentration. So we use our formula, pH equals negative log of our H3O plus. It's hard to write on this thing. So I just go negative log in my calculator of 10. And if you go negative log of 10, that gives you negative 1. And if we want to answer to the right number of sig digs, this has 2. So we'd want to have 2 numbers after the decimal place. So negative 1.00 would be the correct answer. So with the pH scale, every time we go up 1, we're not going up by 1, we're going up by 10. So if I went up on a pH of 3, 4, 5, so if it went up from 3 to 5, I would be going up by 10 and then 10 again. So 10 times 10 would be 100. So a pH of 3 would be 100 times more concentrated than a pH of 5, right? So when questions ask this, what has a greater hydronium ion concentration and by how much more? So hydronium ion concentration means acid. So who's a better acid? Well, my better acids are here, right? The lower the number, the more acidic it is. So 5 would have a higher concentration of hydronium ions, and it would be 10 times more. Right, pH of 9 to 4, well, my lower number would be my better acid, my higher concentration ions. And how much more would it be? Oof, well, I'd have to count that. So this, let me go underneath. So 4 to 5 would be 10, 5 to 6 would be 10, 6 to 7 would be 10, 7 to 8 would be 10, and 8 to 9 would be 10. So I'd go 10 times 10, 100, times 10, 1,000, times 10, 10,000, times 10 would be 100,000 times more. Okay. And this last question, as pH increases, what happens to hydronium ion? So if we're talking about increasing pH, we're talking about the number. We're going this way. So as my pH increases, well, that means that my hydronium ions goes down because it's becoming more basic, which means there's less hydronium ions. So as pH increases, what happens to hydronium ion? Well, it's going to decrease. So if we want to go the other way, so say a pH of a beaker was 2.4 and a pH of another beaker is 7. Well, how do we find the hydronium ion concentration? Well, this 7 is easy because we know about 7, right? If I have a pH of 7, it's just like water, and I know that my concentration is 1.00 times 10 to the negative 7, right? And this 1 doesn't change anything. So really all we're doing is we go 10 to the negative 7, right? So same thing with the 2.4. If I wanted to find it, I would go, oops, I think, yeah, I don't want to write on where that thing pops up. So 10 to the negative 2.4. And if you have a TI calculator, you can get 10 to the by just pushing second log. And sorry, I'll get the calculator program installed so I can show that on screen and I can type that stuff in on screen. I'll get that installed hopefully this week. But if you push second log on your calculator, it'll show 10 to the, and then you type in negative 2.4, and it'll give you the answer of 0.00398107. And if we want to answer to sig digs, this is a pH, so it's one number after the decimal place, so 1 sig dig. So we would want to answer to just 1 sig dig, so 0.004. And we always give the units of moles per liter for our answer, right? So this is our formula. This is in our data booklet with the pH stuff. So you can find that in there in your data booklet. To find hydronium, it's 10 to the negative pH. So let's do another example. So let's use our formula. So to find H3O+, we would go 10 to the negative pH. Right? So on my calculator, I go 10 to the negative 11.50. So remember, you can go second log, and then I'll go 10 to the, and then negative 11.5, and the answer is 3.16227 times 10 to the negative 12. And we want to look at sig digs. So this is a pH, so it's got 2 numbers after the decimal place. This is a regular number, so we just include them all. It's a decimal place. This is above 5, so we want to round up. So my answer would be 3.2 times 10 to the negative 12, and we can put our units of moles per liter. Okay, yeah. So I'll just do this board question. It's the same idea. Oops, blanking out on my screen. So I just want to go 10 to the negative 3.4. So I go second log 10 to the negative 3.4. Make sure you're putting in that negative and use the negative, not the minus. And our answer 3.98107 times 10 to the negative 4, right? This has one number after the decimal place, so 1 sig dig, so we only want to include this one. We got to round that up. So 4 times 10 to the negative 4 moles per liter is going to be our answer. Okay, good luck with that. I'll also post an assignment to work on with it. And yeah, that's pretty much it. So thanks for listening.